All right, folks, we're going to talk about the rules of differentiation, which is Chapter 2, Section 2. And let's go ahead and get started. Due to saving time, I went ahead and did the 3 warm-up problems. You can look at those on Canvas. You can see how they're worked. And if you have any individual questions, you can come see me or contact me some way, shape, or form. I'll be happy to explain them to you. But it would take way too much time. But you've had some experience with it. But please, if you have any questions, do not hesitate to ask me. All right. Now, in the last class, we talked to you about the formal definition, and that involves using the limit process. Well, we're going to take it a little bit differently. As a matter of fact, you might like this method better. You may not even like me after having to do the formal process, but you're young. You'll bounce back eventually. All right. Anyway. Shortcuts. Here we go. The constant rule. If you're taking the derivative of a constant, where C is any member of the reals, then f prime of any number is going to be 0, as long as it's constant. So in other words, if f of x equals 11, f prime of x will be 0. If y equals pi, then y prime will be 0. As long as it's constant, its derivative is going to be 0, because that means that there is no change. There is no instantaneous change. That's why the derivative is 0. All right. And you can do the formal limit process, but you'll still get 0. Okay. Now, the power rule. When dealing with derivatives, and you've got the power rule, if you have x to any power, as long as n is not 0, then f of prime is going to be n times x minus n, or n times x to the n minus 1. If you look at the following, well, this one's not a good example, but x to the third. Well, let's take it back there. All right, x to the third. F prime of x was 3, the exponent, to the x 3 minus 1. Well, 3 minus 1 is 2. I plan on discussing this with you in class so you can see that, but I wanted you to understand how the power rule works. So, for example, for number 4, f prime of x is going to be 7x to 7 minus 1, which equals 7x to the 6th. For number 5, f prime of t is going to be negative 3 to the t, negative 3 minus 1. Well, negative 3 minus 1 is negative 4, which is negative 3 over t to the 4th. Do we need to write it like that? Yes, you should, but know how to do both. At this level, you should be able to write them either way and know what they mean. All right, number 6 is x to the 1/2. So y prime is going to be 1/2 x to the 1/2 minus 1, which is 1/2 to the x. Oops. Let's do it down here. 1/2 to the x to negative 1/2, which equals 1 over 2x to the 1/2. Should you write that? In most cases, yes. Now on AP, they're not going to be as they're going to say keep it as simple as possible, and we'll talk about that throughout the semester and throughout this year. So just be prepared for that. All right, now, what if you have a constant that's being multiplied? Well, here's what you do. The number in front stays in front. It doesn't change. So, for example, for 7, f of x equals 2x to the third. So f prime of x is going to be 2 stays in front, and then I do the derivative of x to the third, which is 3x to the second, because I subtract 1. So it's going to be 6x to the second. Same thing here. F prime of x equals 7 times, and I'm going to put that in there, 5x. I subtract 1 to the fourth. So I don't have my grouping symbols right. Oh, wow. 35x to the fourth. And the same thing goes with 9 prime. I'm going to put 9 prime up here. So y prime equals -8, and then I have 1/2 x. I did it again. I did that in the last problem, or on the last slide. Oops. In most cases, I would tell you I meant to do that, but I didn't. It was a brain fart, so oops. X to the -1/2. Well, when we simplify that, it's going to be -8 over 2x to the 1/2, which is -4 over x to the 1/2. Now, you can also write it as -4 over radical x. Okay. In Algebra 1 and Algebra 2 and pre-calculus, you were told not to leave a radical on the bottom. Well, at this level, you can do that, because on AP, they would want you to do that. Keep it as simple as possible, because you can always make a mathematical mistake, and then that could lead you to delete points. So if you wanted to even leave it like that, that's fine. So just be prepared for it. All right. We're doing pretty good, so I'm sure you're liking the shortcut. It's a lot easier. Okay. Now, the sum and difference rule. Basically, for the sum and difference rule, the derivative d in terms of the derivative in terms of x is f of x plus or minus g of x is f prime of x plus g prime of x. What does all that mean? I'll show you. Basically, you take each individual derivative and you're done. Okay, so now the derivative, I'm going to write this dx of x to the third minus dx of x to the second. Well, the derivative of x to the third is 3x to the second minus 2x to the first, or simply 3x squared minus 2x. So just leave it like that. All right. And remember, this is dx of x to the 1/2 plus x to the fourth. So the derivative of that is going to be 1 over 2x to the 1/2 plus 4x to the third. Exponent goes in front, subtract 1, bada bing. Now you can even write this as if you want to as 1 over 2 radical x plus 4x to the third. You can do that if you like. Or you can leave it like 4. I'm good with that. But just know that both terms work. Okay, now, a couple more. We're actually getting pretty close to being done, so that is good. I'm just double checking my stuff to make sure that we are headed in the right direction. Okay, now, a couple of components that you need to be aware of. First of all, the derivative of sine of x is cosine of x. And the derivative of cosine of x equals negative sine of x. I have 2 words for you. Learn them. Know them. Plain and simple, you need to know them. All right. So, y prime equals 5 times the derivative of sine of x. Well, derivative of sine of x is cosine of x. So basically, it is 5 5 cosine x. There you go. And then for this next one, y prime is equal to derivative of cosine of x is negative sine x minus the derivative of sine of x is cosine of x. And there's a long reason why that is the case, but we'll discuss that here in the near future. Okay. Now, we got that. The derivative of a natural log, the derivative of the derivative of an exponential function. I apologize. The derivative of e to the x is just simply e to the x. So, for example, f prime of t is just simply 7e to the t, because the 7 is a constant. It's just going to stay as it is. Well, the derivative of e is just simply e to the t. G prime of x, the derivative of cosine, as you can see from the previous page, is negative sine of x minus, in this case, 3e to the x. All right, there we go. Now it says determine the equation of the tangent line at the point 0, 1. Okay. I am probably going to run out of time, so I will do a part 2 for this one. It won't take very long, but we will continue this here in part 2.